Good morning to all. Now, in this session, we are going to discuss analogous systems and digital systems. This will be the last topic of the first unit. Now, analogous systems and digital systems This topic today is the last topic of this first unit. Before that, just we discussed continuous time signals and discrete time signals or systems. Look at these two topics. More than 75% of the content of these two topics are same. If anyone asks analogous systems and digital systems or continuous time systems and digital time systems, these two topics seem to be separate one, but these two contain 75% of the similar topics, both one, because continuous time signals, another name of continuous time signals is analogous. Another name of discrete time signals is called digital. Understanding? So these two are just this type of difference we could find, only small difference, 20 to 25% difference. The content of these two topics will be like that. Now just look at first one. Now we are going to discuss analogous. Here we are going to discuss digital time signals. This is analogous. This is digital. Analogous signals means what? These systems contain continuous time signals. Analogous systems, they contain continuous time signals. Look at analogous. Analogous signals, they contain continuous time. Analogous systems, they contain continuous time signals. On the other hand, digital systems, they contain discrete time signals. They contain discrete time signals. Now, these analogous systems, actually, it contains all input as waveforms. In the waveforms, that means are in the sinusoidal representation. They are in the waveform or in the sinusoidal representation. Now, on the other hand, the digital systems, what kind of data it produces? It always produces discrete time data. Discrete time data. Here, the concept is closure interval. The concept is closure interval. Here, the concept is sequences. The concept is only regarding sequences. Sequences means what? It contains only integers. It doesn't contain any decimal numbers between the integers. That is the meaning of sequences. Sequences means you already come to know. We described it so many times. Here we use closure interval. Closure interval means what? Square braces. Now, here these signals, just look at continuous time signals. These signals requires less space. It occupies less space. These signals occupy more space. So these signals require less power consumption. It needs more power consumption. More power consumption. So less space, less power means what? Automatically cost is less. That means cost effective. This is cost effective. But here, just look at, it requires more space. than this one. It requires more power than analogous. So automatically cost will be increasing. Therefore, it requires more cost. It requires more cost. But why do we use everything in digital? Because it is less efficient. This is less efficient. But digital, it is more efficient. It is more efficient one. This concept is more efficient. So digitalization is a concept that always has more efficiency than that of analogous systems. That means than that of continuous time signals. Now just look at the comparisons between all these two. Got it? Now, next one. Now, these are analogous. Now come this side. Here, to describe analogous systems. To describe analogous systems, we use Fourier series. Fourier series. And we also use Laplace transformations and Fourier transformations, Laplace transformations. Transformations. That means what? To represent, to model analogous systems which contains continuous time signals. Here, the mathematical representations are possible only by Fourier series and Fourier transformations like that under analogous system. Same the concept, how to represent digital systems functionalities mechanism by using discrete Fourier transforms. Discrete Fourier transforms. Now just look at the word itself is also discrete. Discrete cosine transformations, discrete sine transformations, like that. Everything is discrete, digitalization. But here, wherever there is analogous, analogous means what? Continuous. Continuous means what? The representation will be possible only by Fourier series and Fourier transformations. These two are very much important. Students have to differentiate because you already did all these concepts in your previous semesters. Now, another point. Now, just look at the main purpose of the applications. Where do you use this one? How could you find the difference between analogous systems and digital systems like that? For example, just look at your computer system or mobile is here. Your computer system or mobile is here. Now, from this mobile or computer system, we are sending a message. This message has to reach to another computer system or mobile. This is computer 1. This is computer system 2 or mobile 1 or mobile 2. These email or messages are to be sent to that computer system. For example, computer 1 or mobile 1, whatever it may be. Mobile 1 or mobile 2. Now, the transformation could be through cable wires, in which these two computers are within the limited location. But you are in, for example, Hyderabad. If you wish to send the same thing to abroad, US or something, anywhere other than Delhi, Bangalore, like that, if you wish to send in your email, this should be done only by which one? Wi-Fi, wireless fidelity. Now here just look at, that's why in computers there is an instrument, powerful instrument, that is called modem. Modem means what? Modulation. Here DEM means what? Demodulation. Demodulation. In the modulation, what happens? Whatever the message we type, we type on this monitor. Everything will be what? Continuous, analogous. These continuous message, by using modulation, it will be converted into digital. That means this continuous message will be converted into digital form by our mobile or computer. Then it will be sent to the corresponding, if you see message mobile to mobile, the message will be sent to which one? Satellite. Now from this air to satellite, the formation, digital formation has to travel, has to reach to satellite. Then the satellite gets the address of the message. That according to that address it recorded, immediately sent to the to address, in the to address. That means what? Now just look at, this is the location 1, this is the location 2. Now we are sending the message through the modem. This modem converts continuous to digital. Now it will go to the satellite. Now the satellite again sends the digital message. The digital message it receives by demodulation process. Their demodulation process, this analogous is again this digital is again converted to analogous. Now just look at, so what are the messages we send on the mobiles or computer systems through Wi-Fi? All these messages are of which one? Continuous formation, analogous system. There the message will be converted to which one? Digital. That means what? By using modem. Once the digital message, so in the air, only digital format of the messages will be traveling, only digital messages, not analogous. Now all these digital messages again reach to another system where demodulation. In the demodulation what happens? Digital will be converted to analogous systems and digital systems. That's why every electronic system, computers, laptop or mobile phones, everything, they contains these type of formations. Here one important point I have to mention that in the analogous form, in analogous systems, these continuous time signals are very prone to be affected by noise or any changes in the weather, thunders like that. So here one important point. Regarding continuous analogous systems, these analogous systems, what they use? Analogous systems use continuous time signals. These continuous time signals are very prone to be affected, by noise in the weather or noise in the cables or what it may be, everything noise. That means what? The actual signal will be affected, it will be corrupted, the message will be corrupted. Others may not receive the message exactly. For that purpose, all these continuous time signals, they will be converted into which one? Digital time signals. Digital time signals are not prone to any kind of noise. They are not prone to any kind of noises. That's why they are very efficient. What is the purpose of efficiency of these digital systems? Digital systems use what? Discrete time signals. These discrete time signals are not prone to any kind of noises in the weather. These noises due to cable wires, due to systems, what it may be, regarding the power ups and downs, everything. All these effects we call it as noise. So discrete time systems, discrete time signals, that is digital time systems, they do not be affected by any kind of noises. So here continuous time signals are used by analogous systems. Here they will be affected by noises. That is the region of efficiency of this one. One more point, continuous time signals requires less, digital require more. The last point is that continuous time signals, they require low bandwidth. They required low bandwidth, but digital systems, discrete time signals, they require high bandwidth. That's why every time we require more bandwidth because of the traffic. This is very important. Continuous time signals require low bandwidth. Discrete time signals required high bandwidth. Whenever the bandwidth is high, automatically speed of the data will be increased. Here, low bandwidth means what? Just like our roads, narrow roads, traffic is very high, very congested. Same concept is applicable to virtually concepts. So those are physical live examples, these are virtual live examples. So these are the differences between analogous systems and discrete systems. So this ends the end of the unit 1. Now in the next session, we are going to begin with unit 2. Thank you.